Okay, so this talk is about what I call IPv4 heat maps. This talk has a lot of pictures, and some of you have seen these pictures already, either online or maybe around here. And this is the source of a lot of this is the inspiration for the work that I did and the work that a number of other people have done, which I'll get to at the end. If you haven't seen this picture, this is a comic called XKCD, and this came out, I think, earlier this year or maybe at the end of last year. And it was a really clever way of organizing the IPv4 address space, and it's labeled and everything. So his map uses a Hilbert curve, and if you've never seen a Hilbert curve, this is an example of one. This is a fourth order Hilbert curve, and the idea is that you sort of start here and work your way around, and eventually you fill up the whole space. And if you need sort of more points, you can, for example, go to a fifth order Hilbert curve, and it gets denser, but it preserves properties of grouping and fractal nature and everything. So I've got sort of a pseudo animation here that shows you the layout of a Hilbert curve, and I'll sort of step through these one at a time. The numbers represent the first octet of an IPv4 address in the map. So this is 0/8. There's 1/8, and so on. And so it goes like this. I'm not going to go through all of them one by one. Here's the next chunk, and so on. So that's all 256/8s in the IPv4 address space, and the color represents the color is related to the number, obviously. I'm going to back up a little bit and make one more point clear. So here's a /8 sized chunk. Here's a /7 sized chunk. Here's a /6. Here's a /5. So what's nice about this map is that cited prefixes are always squares or rectangles. There's a /4, /3, /2, /1, and so on. This little picture shows the address space in the map, colored by the old pre-CIDR nomenclatures. So class A, B, C, D, and E. This picture is the first data set that I actually visualized using the software. This is represents the locations of OpenDNS resolvers in a survey done by John Christoph. And so he made his data set available to me and some others, and I was really curious to see, how it looked. So whipped up the software, and this is what I came up with. I realized that at this level it's really hard to see. So I have a sort of here's a zoom-in section on some ripe address space, and you can see different patterns, and different blocks have different characteristics. Like for the most part, the dark blue represents about one address open in that /24. The lighter blue, I have to go back to the scale here, but when we get into these lighter blues, we're talking 30, 40%, and so on. And here's another map. This is from RouteView's data. This is a BGP snapshot taken about a month or so ago. And here the color represents the size of an announcement in the routing table. And so one thing that sort of stands out is you can see, up in this corner is the really early Class A holders. Here's a lot of RIR allocations, ARN, APNEC, and so on. Here's a lot of the early Class B, and it just looks a lot different. Here's the old Class C space. I'm going to zoom in on one section to highlight some of this. This is obviously 15, 16, 12, and 17. But you can see, for example, that this visualization shows that different prefixes in the routing table overlap. So for example, the purple represents something like a /8 announcement, and then the blues and the greens are more specific routes. And Obviously, AT&T has a lot of very specific routes in the table. Here's yet another map that uses whois data to generate the colors. And another thing that's sort of interesting about this is, like, I don't know if it shows up on that screen, whoops, but this is kind of a brown area that comes about from the combination of this space being listed in multiple RIR whois databases. I think in this case it's Aaron and Ripe. This picture is from the census that ISI recently published and has been doing for a few years. The colors here represent round trip time in milliseconds from ISI to their targets. Just yet another way of looking at these types of data sets. So as I said, in doing this work, at first I thought I was being really clever and unique and I would be the first one to do this, but of course that's never the case. And these URLs point to people that are currently doing the same thing or have already done the same thing. The first one is a tech report from Pennsylvania that came out in 2005, and they have some visualizations using this technique, visualizations of BGP data using that technique. And the monkey.org URL is interesting because they've put the data into the Google Maps interface, so you can zoom in and you can type in your IP address and it'll put up a little flag where your IP address is. ISI I mentioned, they've used the same technique and recently published their data. There's a couple others there. There's a URL where you can download the source code for this. You can browse some full-size images, which I highly recommend because they don't come out very well on the screen here. And there's also some animations. And if I have time and there's no questions, I have an animation that I could maybe show on the screen. How much time do we have?
You have 3 minutes.
No. Are there any questions, or should I try the... See if I can find a USB. I didn't test this beforehand, so I have no idea if it's going to play. Did I lose it? It's kind of a big file, but yeah. Well, if it works, it works.
If not, I think what I think we do need to do is try and get the meeting back on time. So,
okay.
Is this online somewhere?
It is online, yeah. It's like a 36 megabyte file, so it's a little bit big, but it is online. Yeah.
Okay, right. Well, and the URL's there in the slides, so that's easy to get. So if there's no questions, I think what we'll do is we'll go into the coffee